Hello again to Geomat Simplified. Today we are continuing our circle geometry series and we are looking at the third theorem, Theorem 3. Let us get right into it. So just like every other theorem, we are also going to state Theorem 3. The statement of Theorem 3 just goes as follows. Angles in the same segment are equal. So very quickly, before we dive into what this theorem actually means, what is a segment? Because you really have to understand what a segment is to understand this theorem. Now, from theorem 1, you remember when we talked about the chord, I said if you are given a circle, a chord is just any line that partitions or divides the circle into two unequal parts. So if I draw this line in this circle, that line is called a chord. Now, if you notice, this chord divides this circle into two regions. We have a smaller region over here, and we have a bigger region over here. Instead of calling them regions, the right word is segments. So this chord divides the circle into two segments. So there are two segments. We have the bigger segment, or we otherwise call it the major segment. So this segment is called major segments. And the smaller segment is called the minor segment. Okay? So those regions enclosed by the chord and the arc is what we call segments. Now, if I draw a shape that looks like this, do you notice that an angle will be formed here and an angle will be formed here? An angle will be formed here and an angle will be formed here. So let me just lay the angle A, angle B, angle C, and angle D. These are all angles in the same segment. Okay? And from theorem 3, what it is telling me is that these angles are going to be equal. So the implication of theorem 3 is that angle A is equal to angle B, and angle C is equal to angle D. Why? Because they are angles in the same segment. So this is an example of a question that can be given to you, and you can see you are asked to find the lettered angles R, U, V, T. Okay? To obtain these lettered angles is quite simple. All you need to take note of is theorem 3. Okay? So by inspection, I see that U and 60 degrees, they are angles in the same segment. Okay? So if this is a chord, this is a segment, you can see that U and 60 degrees are angles in the same segment. So I can just conclude by saying U is 60 degrees. Okay? Moving on. I do the same thing for 40 degrees and V. They are also angles in the same segment. So I just conclude V is 40 degrees by theorem 3, angles in the same segment. Okay? I do the same thing for T. If I take this as my chord, I notice that T and 10, they are also angles in the same segment. So T is 10 degrees. Okay? Finally, for angle R, to get R, I will need to do something quite different. Now, I will need to get this angle. Okay? And to get this angle actually is quite simple. If you look at this shape here, you notice that it is triangular in nature, and I know that the sum of angles in every triangle is going to be 180 degrees, and I notice that this already gives me 100. 60 plus 40 being 100. So what I'll be left with here is 80 degrees. So it is sum of angles in a triangle. Okay, so to continue, I will also need to cut this angle. Of course, this is a straight line, okay? And the sum of angles on every straight line is also 180 degrees, meaning that this angle here is 100, okay? 180 gives me the sum of angles on a straight line. Okay, so R becomes very, very easy. I see that this is 100 degrees, this is 10 degrees. Also, if you consider this shape, you have another triangle. And if this is 100 and this is 10, and I know that the sum of angles in every triangle is 180 degrees, it means that angle R must be what is left from 180, taking away 110, that being 70 degrees. So I just conclude R is 70 degrees. Okay, so you see that I have been able to apply theorem 3 to get the lettered angle.